Children, and hi everyone. In previous video I explained about the how we can find electric field intensity at a point on axial line of dipole. Clear, children? So up to now you didn't see that one, you must watch it. Clear? And today I am going to explain about we want to find out the electric field intensity at a point on the equatorial line of the dipole. Today topic is already we want to find out the electric field intensity at a point on the equatorial line of a dipole. That is the topic for today, children. And if up to now you didn't subscribe my channel, please subscribe my channel and press the bell icon for latest notifications. So here I am going to the topic now. My request is from my side, it is please watch the video without skipping, then only you can understand the topic very clearly. Okay, so I am going to topic now here. Today our topic is electric field intensity at a point on the equatorial line of a dipole. So in previous video I explained what is mean by dipole and what is mean by dipole moment. So even though, let us see once here what is mean by dipole. Dipole is nothing but two equal charges and opposite charges. Two equal and opposite charges. So this is the minus q and this is the plus q. They are separated by some distance. Now it is called as a dipole. Dipole is nothing but two equal and opposite charges are separated by some distance, and the line should be passes through the two charges. That should be nothing here. What it is? A dipole. Dipole, it is a combination of equal and opposite charges and they should be separated by some distance. Clear? And now next thing is what? Dipole moment. What is dipole moment? So here I clearly explained about the dipole moment and its dimension formula in previous video. Then go and watch it once. Here P is equals to 2A into Q. Here 2A is nothing but here this is the distance of or length of the dipole. Or distance between two charges. And Q is the magnitude of charge. What is Q? Magnitude of charge. Here for example I am writing here now minus 5 and this is a plus 5. Clear? Now minus 5 and plus 5. Here what is the magnitude? 5. Clear? The magnitude of one charge and dipole length. If we can multiply them, what we get? A dipole moment. Simply dipole moment is the product of length of the dipole and it's one of the magnitude of charge. That should be called here dipole moment. Dipole moment should be represented by the letter P. Clear? And now here in previous video we discussed what's that? Axial line. What is mean by axial line? The horizontal line passes through the two charges. The horizontal line passes through the two charges is called axial line. In this case now here we are talking about what it is? Electric field intensity at a point on the equatorial line. So here what is mean by equatorial line? Equatorial line is nothing but it is a vertical line. That is perpendicular to the axial line, and that should be divides the axial line into two equal parts. That is called equatorial line. For example here I am taking now this is a vertical line. That should be passes through the center, from the center of the dipole, and that should be perpendicular to the, this is what we call axial line. This is what? Axial line. Clear? And here we are taken one line that should be separates the axial line into two equal parts, or dipole length into two equal parts. That should be what we call here. Now this is the equatorial line. So here Equatorial line means what? The line which can bisect the dipole length into two equal parts perpendicular to its length. Here, this is the vertical line that should be passes and perpendicular to the, here what it is, this is the axial line, and for that the perpendicular line is there, that is the equatorial line, and that should be coming from here, midpoint of the dipole. Midpoint of the dipole, what I am saying, that should be divides the dipole length into two equal parts. That means like this, that should be passes through the center of the dipole. A vertical line passes through the center of the dipole and that should be perpendicular to the axial line. That should be called equatorial line. Clear? Now in this case, in this topic, we have to select a point on the equatorial line. We have to select a point on the equatorial line. At that point, we have to find out the electric field intensity. Electric field intensity. Children, first I am going to explain diagram very clearly. After that, I will go for derivation. Clearly? So, you must watch the video without skipping, children. So here, first I am taking the dipole like this. So this is the minus q and this is the plus q. This is minus q and this is the plus q, and now here this is the length and this is the midpoint here. Length how much it is, we are taking 2a. From here to here a and here to here a. Clear, children? After that, now I am taking this one, that is what? Equatorial line. On that equatorial line, at this point, that is the point P we selected, that must be at a distance of r. How much distance? This is the r. Clear? Now at this point P, we have to find out the electric field intensity. Clear, children? This is the equatorial line. So for example, here I am saying now this is the position of minus q is A and this is the position of plus q, that is B. Here, and this is now I am taking O. Now OP is what? Equatorial line. What is that? OP is the equatorial line. Clear? So in this case, we want to find out the electric field intensity at this point P. Clear? So that's why here the point P is in between minus q and plus q. Minus q and plus q. That's why there is some electric field intensity at that point P because of plus q charge and minus q charge. Because the point P what we selected, that should be in the combined field of plus q and minus q. Clear? P must be in the combined electric field of plus q and minus q. That means what? It is in the field of the dipole. That's why on that point there is some effect of plus q charge and minus q charge. That's why here already we know that electric field intensity due to the point is given by E is equals to 1 by 4 pi epsilon naught q by r square. This is the equation for electric field intensity. Clear? Now here this is the plus q charge. At this point there is some electric field should be acts in this direction because it is a positive charge. For positive charge, electric field is radially outwards. I explained in the previous video. Clear? Electric field intensity is radially outwards like this. At this point it is radially outwards. Clear? And due to the minus q charge, here the electric field should be here towards minus q, because in case of negative charge we will show that should be moving into the negative charge. Clear, children? So after that here, now this is what? R. This is what? R. Clear? Now here general, what is the general equation actually? E is equals to 1 by 4 pi epsilon naught q by r. Here what is mean by r? Distance from charge to the point. in general expression we have E is equals to 1 by 4 pi epsilon naught q by r square. Now distance from r means what? Distance from charge to the point. Clear? So that's why here in this case also we need to find out the distance from plus q charge to the point P, and similarly we want to mention the distance from minus q to the P. Clear? So for that we are taking the diagram should be like this. So here now what is this is the R, this is the R, and this is what A. Clear? So already we are seems like this. This is R and this one is A. Clear children? Now here it is a right angle triangle, that's why it is hypotenuse. Clear? This is what? Hypotenuse. So according to Pythagoras, what we say? For example, I am saying this is x. Then what write? X square is equals to r square plus a square. That means square of the hypotenuse is equals to side square plus side square. Children, very important diagram. The entire concept in only diagram. If you can understand diagram very clearly, the derivation is very simple. Clear? So in this case what I am telling, we want to find out the distance from plus q charge to the P. For that I am taking the triangle now. This is what? Triangle POB. This is what? Triangle POB. Like this POB. Here that is by what? That is nothing about what it is. Pythagoras theory. What it is? Hypotenuse square is equals to side square plus side square. Then here what is hypotenuse? BP square is equals to OP square plus OB square. That means what? Simply here R square plus BP value is what I am saying X, R square plus A square. Clear? X square is equals to R square plus A square. Then what is the X value? Here under root of A square plus R square. Clear children? Very important children. Here in this case we are taking the triangle now POB. So it is the right angle triangle. According to Pythagoras, what do you write? What do you write? Hypotenuse square is equals to side square plus side square. Then what do you write? BP square is equals to OP square plus OB square. Then what do you write? OP, nothing, BP is what? X. So X square is equals to OP square is what? R, and OB square is what? A square. That's why here the distance from plus q charge to the point is what it is? What do you write? As under root of R square plus A square. So similarly, if you can take same thing, this is what? Minus q, and this is the P. Again this is what? A. Total distance is 2a. Midpoint to here it is A. Here to here it is A. Then what do you write? This is also same thing. R square plus A square. Clear children? So this is the diagram. So after that we go for that one. And next here, so in a first year it is there, parallelogram law of factors. Parallelogram law of factors. Here I am saying now this is the plus q charge. Due to that some electric field it is there. That should be in this direction. That should be in this direction. And next, this is the E1 and this is the now E2. E2 is what? Electric field intensity due to the negative charge. Now these E1 and E2 are taken as the sides of a parallelogram. Then we are constructing one parallelogram like this. Here this is the parallelogram. Now E1 and E2, and now it is the E. E is the resultant electric field intensity. This is the E. Clear? We want to find out this E value. In first year we know parallel law of vectors. If two vectors are taken as the adjacent sides of a parallelogram, then the resultant must be here diagonal. Like that, here with the help of E1 and E2, we are drawn from same, two vectors are drawn from same point. From the P point we are drawing E1, from P point we are drawing E2. E1 and E2 are taken as the adjacent sides of a parallelogram, and we are constructing one parallelogram. Then the resultant is what it is? E. That is diagonal. So now we want to find out that E value. Clear, children? So this is about the complete diagram. Look here once, very important. We are taken now a dipole of length 2a. Clear? And here OP is the equatorial line, and at this point we want to find out the electric field intensity. At this point we have to find out the electric field intensity, and due to plus charge here E1 is acting in this side, and due to minus charge E2 is acting in this side. I already told you electric field intensity is a vector quantity. Electric field intensity is vector quantity. That's why we are representing in terms of vectors. That's why here E1 plus Q is what? Plus Q means what here? Positive charge. And due to the positive charge E1 is there. That E1 is always radially outwards. And minus Q means what? Negative charge. Due to the charge, some electric field it is there. What is that? E2. That should be towards. That means into the negative charge. That's why I am showing like this, E1 and E2. And these two are taken as adjacent sides of a parallelogram. Then by E is the here nothing but E is resultant of these two. I mean E is the diagonal of the parallelogram. That's why here E should be taken as the resultant electric field intensity. E is the resultant electric field intensity that we have to measure. Clear? Now I am going for the derivation. Look here. Again I want to draw the same diagram here. Same diagram, very simplified to understand very clearly. Now this is the minus Q and this is some plus Q. Here the board is not spacious, that's why I am again drawing very shortly. This is minus Q and this is plus Q. Here this is the point here, what it is? P. Clear? And I am showing this is like this. Here that is what? E1. That is what? E1. And due to negative charge it will be there. What is that? E2. What is that? E2. And this is what we are constructing some parallelogram like this. That parallelogram is nothing but here S. So that is I am drawing here. Otherwise simply here, look here, we will adjust this only. Okay, this is what here now at this point P. At this point P we want to find out the electric field intensity. So for that I am taking now here at P. At P electric field intensity. Electric field intensity due to plus Q. What is that? Due to plus Q. So what is general formula? E is equals to 1 by 4 pi epsilon naught Q by R square. This is the general formula. So here now I am writing, by using that I am writing E1 is equals to, what is that? E1 is equals to, again what to write? 1 by 4 pi epsilon naught into Q by, here R means what? Distance from plus Q charge to the point P. What it is? As it is. So under root of R square plus A square whole square. Clear, children? This is general equation. E is equals to 1 by 4 pi epsilon naught Q by R square. Here R square. Here what is the distance now here? Plus Q charge to the point, what it is? Under root of R square plus A square. So here R square plus under root of R square plus A square whole square means what weight? R square plus A square. That's why I am writing here E1 is equals to 1 by 4 pi epsilon naught into Q by R square plus A square. Now this is the equation number 1. Clear? This is what? Electric field intensity because of plus Q charge. Similarly here now electric field intensity due to the minus Q charge. Again same formula. What is that? E2 is equals to what, right? 1 by 4 pi epsilon naught minus Q by again what is the distance from minus Q to the point P? Again same thing, here both are same. That's why I am writing here directly R square plus A square. That is now equation number 2. Equation number 2. Now if we can consider magnitude, here minus means what? Opposite sign. Opposite sign means opposite direction it is showing. So that's why here if you can consider magnitudes, what do you write? E1 is equals to E2. Clear? That means here the point P is on the equatorial line, and at that point P, plus Q charge and minus Q charge creating the same amount of electric field intensity. That means the intensity created by the positive charge must be equals to the intensity created by the negative charge. Both are applying same thing. Clear? So now in this case I am going to explain now here. We want to find out the E. What is E? Resultant of E1 and E2. Clear? So that's why in this case now here we are giving one comparison now here. For example, this is P. I am taking this is Q, and this is R, and this is S. P, Q, R, S. It is a parallelogram. P, Q, R, S is the parallelogram. And again you have to observe, I am taking the two similar triangles, triangle PQR. Triangle PQR is similar to the PAB. Clear? That means, watch carefully children, here PQRS is the parallelogram, it's very clear, and PR is the diagonal. Clear children? And after that I am comparing the two triangles. One is PQR, it is one triangle, and PAB, it is another triangle. So here let triangle PQR and triangle PAB are similar. So we know that in similar triangles the ratio of the sides should be equal. That's why here we are writing PQ by BP. Symbol. This is what? PQR. And next one is what? PAB. Now here we have to write the ratio of same sides. PQ by PB or BP and PR by AB. Clear children? I draw separately children here. PQR is one triangle here and PAB is another triangle. We have to compare these two. Now here we have to write the ratio of same sides. PQ by BP and PR by BA. So I am writing here PQ by BP. PQ by BP is equals to PR by AB. PR by AB. Clear? Now this is equation number 3 children. So here now you have to observe what is PQ? What is PQ? It is E1. What is PQ? E1. And what is PB? PB value is what? Under root of R square plus A square. PQ by BP. PQ by BP. PQ value is E1 and BP value is under root of R square plus A square. And now here PR. PR is what? E. PR is what? E. And AB is equals to what? Dipole length. That is what? 2A. So that's why I am writing here. PQ is equals to what? E1 and PR or BP. BP is equals to what? BP under root of R square plus A square. Under of R square plus A square. And next thing is what? PR. PR is what? E. Resultant intensity. What you have to find? That is PR is equals to E. And after that AB. AB is equals to what? Dipole length. That is what? AB. That is what? 2A. Clear children? PQ is equals to E, BP is equals to under root of R square plus A square, and PR is equals to E and AB is equals to 2A. Now we have to substitute all these values in this equation. Clear? I am writing here. What is PQ? E1. What is meant by PQ? E1. E1 means what again? What it is? This one. PQ is equals to E1. From equation number 1, E1 is equals to what? 1 by 4 pi epsilon naught Q by R square plus A square. That's why I'm writing here. PQ by BP means PQ is what? E1. That's why I'm writing 1 by 4 pi epsilon naught Q by R square. 1 by 4 pi epsilon naught Q by R square plus A square. PQ by BP. What is BP? S by under root of R square plus A square. Under root of R square plus A square. That is equals to PR. PR means what? E. PR means what? E. Clear? By AB. AB is equals to what? 2A. AB is equals to what? 2A. S. Children, no need to confuse. Very simple. We have equation number 3 is there, and in that equation we have some terms are there. For the terms, we have some values are there. What is PQ? PQ is E1. E1 means what? 1 by 4 pi epsilon naught Q by R square plus A square. And what is BP? This one, under of R square plus A square. And now here AB is equals to what? Dipole length 2A, and PR is equals to what? E. PR is equals to what? E. Clear? So from that I am writing now here E is equals to, I am taking this side, 2A. E is equals to what? 2A into Q. 2A into Q by, I am writing like this, 4 pi epsilon naught into R square plus A square. R square plus A square into under root of R square plus A square. So simply we are writing E is equals to 2AQ by 2A into Q. E by 2A, denominator is there. If that will go side into. So multiplication 2AQ by 4 pi epsilon into R square plus A square into under root of R square plus A square. Children, if you have like this, x into root of x, root of x, x into root x means what? X over of 1 into x over of 1 by 2. Here bases are equal. That's why we have to add the exponents. Then what to write? X over of 1 plus 1 by 2. 1 plus 1 by 2. That means what? X power of 3 by 2. Clear? We know that x and root x. X means what? X power of 1 is there. Root x means what? X power of 1 by 2. X power of 1 by 2. And when bases are equal, we have to add the exponents. That's why here x power of 1 plus 1 of 2. That means what? X power of 3 by 2. Clear? Like that, in that equation, instead of x, what you have? R square plus A square. What you have? R square plus A square. Clear, children? So now, that's why I am writing here E is equals to 2AQ by what do you have? 4 pi epsilon naught into R square plus A square whole to the power of 3 by 2. Here R square plus A square. R square plus A square under root of means what, right? Simply whole to the power of 1 by 2 we can write. Already R square plus A square, x is there, x to the power of 1 by 2 is there. Then what do you get? 3 by 2. And already told you 2AQ means what? Dipole length into magnitude of charge. What do you write? Yes, what do you write? Dipole moment. Then what do you get? E is equals to P by 4 pi epsilon naught. 4 pi epsilon naught into R square plus A square whole to the power of 3 by 2. This is the, children, this is the expression for electric field intensity at a point on the equatorial line. So you can observe that in case of axial line, we got the expression 2P. 2P by 4 pi epsilon naught R square plus A square whole to the power of 3 by 2. Okay, children, this is the expression for electric field intensity at a point on the equatorial line of the dipole. Okay, see once clearly. Very important chapter for 4 marks. Very important topic for 4 marks in the IP examination, children. That's why you have to watch carefully. I want to say again, once again, children, what is equatorial line? Equatorial line is nothing but a line, vertical line, which can pass through the center of the axial line or dipole, and that line is perpendicular to the axial line. That is what we call equatorial line. In this case, we are taken one dipole, that is what length 2a is there, and minus q charge is there, plus q charge is there, and OP is the equatorial line. At this point P, we have to find out the electric field intensity. That's why here what I am telling, there is some here distance is what, plus q charge to the point is under root of r square plus a square. I already explained how we can get that one. So r square plus a square. Similarly here also distance is what, r square under root of r square plus a square. Clear? And here the first thing, at the point P, electric field intensity due to the plus q charge, what is given, 1 by 4 pi epsilon into q by under root of r square plus a square whole square. This is only when we will consider general equation. 1 by electric field intensity due to a point charge is given by E is equals to 1 by 4 pi epsilon into q by r square. In that r is what, distance from charge to the point. Like that here distance from charge to the point is what, under root of r square plus a square. That's why I mentioned like that. This is the E1 is due to the plus q charge, and similarly for negative charge we have to get minus. And if you can consider magnitudes, both are equal. That means what we proved, at a point on the equatorial line, plus q charge and minus q charge will apply the same electric field intensity. So after that we are taking now here, we have to construct the one parallelogram. At this point this is the E1 and this is the E2. By using those two, what you have to construct, one parallelogram. Clear? So in our first video, how it is there, parallelogram law of factors. If two vectors are taken as the adjacent sides of a parallelogram, then the diagonal must be used a resultant vector of those two. Like that here, by using this E1 and E2, we are constructed one parallelogram, and now this is the diagonal. Now this is the resultant value. To find out that, we are taking the two triangles. Well, first triangle is what, PQR, and now PAB. These two triangles we are taken. So after that we are taking them, both are similar triangles. That's why we are writing PQ by BP is equals to PR by AB. So let triangle PQR and triangle PAB are similar. We are writing equation number 3. After that we are having some PQ values E1 and PB values under root of r square plus a square, and PR is E and AB is equals to 2A. And now we are substituting all these values in equation number 3, and PQ is equals to E1. Already E1 is there in equation number 1. So E1 is what, 1 by 4 pi epsilon into Q by r square plus a square, like that. So we are writing like this. This is the E1. So here after substituted by the all values, what we get, E is equals to 2AQ into 4 pi epsilon into r square plus a square whole square into like that. So they are in the form of x into root x. That's why we already write r square plus a square whole power of 3 by 2. So here 2AQ means what, dipole moment. So this is the expression for the electric field intensity at a point on the equatorial line of the dipole. So in competitive exam point of view, some comments are there, some statements are there here. So you have to observe here. In competitive exams they will be asked like this here. It is what, E equatorial line, that is what, P by 4 pi epsilon naught into r square plus a square whole power of 3 by 2. This is the electric field intensity at a point on the equatorial line. So if you can take R is so greater than A, R is so greater than A, or A is so less than R. That means we are taking a short dipole. We can take a short dipole. Then this is the first point here. Then we can consider what it is. We will neglect the A value. Then what we get? E equatorial is equals to P by 4 pi epsilon naught into what we get? R square 3 by 2. A is negligible. That's what we get. E equatorial is equals to what we get? P by 4 pi epsilon naught into R cube. To do cancel. So now this is the electric field intensity of a dipole of short dipole. Clear, children? So in any problems he was directly mentioned that is a short dipole. You can go for this formula. P by 4 pi epsilon R cube. Clear? So after that, here this is what epsilon naught. What is the epsilon naught? Permittivity in free space. What it is? Permittivity in free space. So already we know that epsilon r is equals to epsilon by epsilon naught. Here what is epsilon r? Relative permittivity. And what is epsilon? Permittivity of medium. And what is epsilon naught? Permittivity of free space. From that what you write? Epsilon naught is equals to what, right? Epsilon is equals to what, right? Epsilon naught into epsilon r. What is epsilon? Permittivity in the medium. That means we are having some epsilon naught means what? Epsilon naught is the permittivity in free space. If we can do the same thing in the medium, then how we can write? In a medium. In any medium. Then what do you write? E is equals to P by 4 pi epsilon naught. 4 pi epsilon naught means here what, right? Simply here epsilon. Epsilon by r cube. Then already what is the value of epsilon? Here we have E is equals to P by 4 pi epsilon naught epsilon r cube. So epsilon is equal to epsilon by epsilon naught. Then epsilon is what? Epsilon into epsilon naught. Like that. And we have one more thing, it is there. You can observe here simply for axial line, electric field intensity on axial line, what it is? Don't confuse children. In that we have 2p by 4 pi epsilon naught r cube. This is the electric field intensity. This is what? Electric field intensity for axial line. And this is for what? Electric field intensity on equatorial line. This is what? Electric field intensity on axial line. This is what? Electric field intensity on equatorial line. If you can write EQ by E equatorial by E axial, then they are in the ratio of 1 by 2, 1:2. Clear? This is the electric field intensity on axial line. This is the electric field intensity on equatorial line. If you can write equatorial by axial, then what do you get? They are in the ratio of 1:2 or 1 by 2. So this is the children. So this is the most important question. I hope you understand. So if you can understand the topic, like, share and comment the video. And to get all the videos from my side to you, then go for and subscribe channel and press the bell icon, children. So I hope you understand. We will meet in the next video with the next topic. Bye. Take care. We will meet in the next video. Take care.